I finished replacing all the capacitors and pretty much all the resistors. I found something kind of interesting while working on this, though, is that there are subtle differences between this board and the 9L37. Right over here. They look the same, pretty much, but there's one area difference over here. Here we've got a couple resistors. Here we don't. And there are some component value differences. For example, here we have 15K right next to this tube socket, and here we have 12K. Here we have, I think it's 3.3K, here we have 3.6. In other words, this 9L38 chassis has some values that are a bit oddball. So in some cases I've had to double up resistors in series, like a 10K and a 2K to get 12K. In here the original 3.6 was close enough that I just left it in place because I didn't have any 3.6 on hand. And those are standard values, 12K and 3.6 can be had. I just don't have any on hand, and I really don't want to place an order for just a couple resistors. So we'll see if I end up needing enough parts for other projects or this project before time comes to reinstall this board. I will try to order up those resistors and replace them. Otherwise, I'll go with these as they are. Now, in that same vein, these networks have been fun to work with too. First off, here's one that had the resistor soldered across it. And indeed, that was there to bypass an internal one. If I measure between pins 2 and 6, I've got almost 19K, and it should be 4.7, I believe, or thereabouts. So they figured if you put a 6.8 in parallel with that 18 and change, you get around 4.7 or so. So that an internal resistor drifted off quite badly. Alright, well, I'm going to be replacing the whole thing anyway, so that's fine. But I was looking at the schematics. So I just assumed that the 9L37 and 9L38 use the same K networks, but they do not. Very similar, but not quite the same. So if we look on these two networks here, zoom in on that. I think I'll just go handheld for this. So here is one network, and here is the corresponding one. And this is a 9L37 holiday, 9L38 tandem set. My ink cartridge is running out, so it's a bit different looking. Well, that's good. It's an easy way to tell them apart. Now, first, I'm going to notice right away. Here, 39K. Here, 47K. But also, check out these two capacitors. Here they share a common point, which is pin 7. Here, it's subtly different. This one, the 330, is going to pin 2, not to pin 7. Over here, it's going to pin 7, not pin 2. So, I was all ready to go ahead and, oh, okay, and if you look at the parts numbers in the parts list, they are actually different too. So I figured, okay, for whatever reason, design change, whatever, this is the way I'll build it. However, just so happened to have this Philco publication of a pocket service guide that has both sets in it. Here is the 9L37, and network's drawn a bit differently, but we can see it here that both of those capacitors come up to that node, which goes to pin 2, which matches the SAM service info. Now the 9L38, remember the SAMs shows that 330 going to pin 7, not to pin 2. But if we look in here, they've got the 330 going to pin 2, just like on the 9L37. And in fact, if you look more closely, the only difference in the actual Philco service info between the two is just that resistor. 47K here, 39K here. Otherwise, they're wired up identical. And in fact, the part number here, 306512-7. Here, 306512-6. So I think the 30-6512 indicates the basic wiring inside, and the -6 and -7 are just variations on the internal component values. So in other words, I'm saying the SAMS is incorrect. And I found one other mistake as well with the SAMS for the 9L38 chassis with these resistor values. I believe it was these two. This 1.8 mag and the 470K. They had these flip-flopped in the component locator and the corresponding parts value. So that's not exactly reassuring, but I'm glad I've got this, which I trust a lot more than the SAMS, since it was actually published by Philco. So I am going to go by this when I rebuild those networks. And if you ever work on one of these, keep in mind the 9L38 uses slightly different values than the 9L37. I was getting ready to lay out the components to fabricate the replacement for this guy with that hacked on resistor when I noticed something. The part number on this is 6519-2, but look what the schematic calls for, 6519-1, and there's that 4.7K that we're supposed to have between pins 2 and 6. Well, not too surprising if you look at the schematic for the 9L37. What does it have? It has a 6519-2, and that is 18K between pins 2 and 6, which is about what I measured. So I wonder, at the Philco factory, did they run out of 6519-1s and they used a -2 with this resistor hacked on? Or is this a later repair? Because this set had clearly been worked on. However, all the components that I saw that were replaced from the top. In other words, somebody did not remove the circuit board to work on it. Which means they could not have replaced this. Of course, there could have been multiple phases of repairs throughout its lifetime. I don't know. Be curious when I pull out my other tandem set chassis to see what that's got on the board. Wouldn't it all surprise me if this was done in the Philco factory, because that is a period correct resistor on there.